is the idea that a power plant or a manufacturing facility or any part of the sector could either pay to reduce its own emissions of carbon dioxide, or that same company might pay to offset their emissions by storing carbon somewhere else around the world. So that's the idea behind an offset. Offsets were a major part of the climate bills that passed in the House of Representatives in 2009, the Waxman-Markey bill, and it almost passed in the Senate last year in the Lieberman and Lindsey Graham and Kerry bill. So offsets are politically palatable because it allows, say, farmers in Iowa to be paid to restore soil organic matter. It is a policy lever that would pay for reduced deforestation efforts internationally in countries like Brazil. So there are a lot of different uses. The idea is trying to use soils and forests to store carbon for us. And these are just some photos. Are we still on here?
Yeah, I think someone just joined.
Okay. So these are just photos of our high CO2 experiments here at the Duke Forest, where we've been growing forests in a high CO2 world for the last 15 years or so. The white rings you see down here are about 100-foot areas where we add extra carbon dioxide into the forests. But the point of the slide here in this case is to think about soils, forests, plant biomass as a tool to take carbon out of the atmosphere, because there's about as much biomass, carbon in plants and more carbon in soils than there is in the atmosphere.
I
Want to say that again? Okay, I'll forge ahead. I'm not sure what that was. Okay, so offsets being a third policy lever. With offsets, you pay people to keep carbon in trees, for instance. So if there's a carbon price put in place, say $15 a ton in this first scenario, $30 per ton of carbon dioxide in the second scenario, and $50 a ton of carbon dioxide, we actually take land, at least in this economic model, we take land out of crop production and move it into forest production. So a policy driver that's pushing land use in a different direction than the liquid transportation fuels, the biofuels one we looked at. So the amount of forestry goes up, cropland area goes down, and this gives you, this lower panel, some sense of how much carbon can be stored. This is forest management, things like changing the density of planting and harvest times. Here is afforestation. This means planting trees that were formerly on pastures or croplands or reclaiming lands. And then bioenergy, the bioelectricity component, grows here, here, and here as the carbon price goes up too. So forest offsets can be substantial with the carbon price, but they trade off some of these agricultural things that we've been talking about. The y-axis now, we're looking at an index value of agricultural prices. And so in this case, in 2030, a 30-year scenario of this carbon price, $15 a ton here, $30 and $50, you see that agricultural prices go up as much as 10 or 20%. And again, that's because you're taking land out of crop production, putting it into something else. So the total production of the grains and other things goes down. And interestingly, our imports of agricultural products go up. That's what you're seeing on this bottom panel. And our exports go down, and data not shown here. So these different policy drivers influence land use, push land use in different directions. And I think the policy community hasn't quite come to grips yet with we're asking our land potentially to do a lot of different things for us, and that you can only do one thing on one piece of land.